Authentication is the digital handshake beginning every session. A user provides their credentials, the system validates the request, and a secure connection is established. On the surface, the interface performs perfectly. It presents the user with a tailored dashboard, ensuring that high-level administrative buttons and sensitive controls remain invisible and inaccessible. But the security of the interface is a facade. By bypassing the visual dashboard and sending a direct command to the system's API, a user can often request data the UI was designed to hide. This documentation highlights the fallout of that specific failure. When a system relies on the interface to hide data rather than the backend to protect it, the result is unauthorized access and a catastrophic exposure of client records. The breach happened because the developers equated identity with permission. They assumed that because a user was verified, they were also authorized, a confusion that leaves the back door wide open. To prevent this, we must isolate the first layer of the security stack, beginning with the process the user successfully navigated: authentication. Authentication serves one narrow purpose. It is the mechanism that answers the question, "Who are you?" To verify that identity, systems use several established methods, ranging from standard single sign-on to magic links or rigorous multi-factor authentication. A successful authentication result creates a state of trust, usually represented by a session ID or a digital token that accompanies every future request the user makes. However, this identity is just a passport. It proves the user is a legitimate traveler within the system, but it doesn't give them the right to walk through every door once they've crossed the border. Restricting movement requires a second, distinct layer called authorization. This is the logic that answers, what are you allowed to do? Role-based access control groups users into broad buckets like admin or developer. For granular control, permission-based access attaches specific actions directly to the user. In complex systems, resource-based access is context-dependent. A developer can only edit documents they own. Returning to our breach, we can see the exact structural flaw. As this documentation warns, the bad approach only hides the admin button in the front end. If the backend API doesn't perform its own independent check, the security is purely cosmetic. The golden rule of secure design is to never trust the front end. Every single request to the API must be intercepted and validated by the backend to ensure the user has the right to see that specific data. Real security is the result of a continuous server-side mapping between a verified identity and an authorized action. Without that link, the system is essentially unprotected. This distinction is becoming even more critical as we move from human to machine interactions to a world populated by autonomous AI agents. These agents act as proxies, navigating the same API pathways at a scale and speed no human could match. Because of that scale, authorization is the final guardrail. These guidelines emphasize that an AI agent must be bound by the same rigorous permission checks as the user who deployed it. If the user can't see the data, the AI can't either. To build these resilient boundaries, developers have to move beyond just writing code. They must proactively map out every actor, every resource, and every potential crossing point long before the system goes live. Shortcuts like undocumented auth overrides or a lack of access logging don't just create technical debt, they create blind spots that make it impossible to audit a breach once it happens. Ultimately, robust authentication and authorization aren't just back-end features. They are the foundational pillars required to maintain client trust and ensure the long-term integrity of the application.